So let us begin to deal with these two questions. The first question is ask us to calculate the density function of z in two methods. The first is the convolution method, and the second is the geometry method. So let's see what I do. The convolution method is very easy to translate in the figure. So first we draw the density function of x and y, and we know that the convolution of these two functions is just to revise x or y. This time we revise f of x, and then shift the revise of the f of x from the left to right, and the answer of the convolution is just the area of the overlap. So that we see at this picture, first we revise the f of x, and it's just like the dot line, and then we shift it from the left to the right, and the overlap of the revised fx and the f of y is just equals to this line, these functions, and this is just the density function of z. We can see as and here, when z is between 1 and 2, the density function of z is just equals to z minus 1, and it is equals to 3 minus z when z is between 2 and 3. Otherwise, it is just equals to 0. And the second method is we use the geometry method. This time we also need to draw the joint density function of fxy. And because of the x and y are independent, so the joint function of x and y is just equals to the density function of x times the density function of y. So we can say the only area that the joint function is not equals to 0 but equals to 1 is between x between 0 and 1 and y between 1 and 2. And the dotted line is z equals to x plus y. What we need to do is just to integrate the area of the area that under the dotted line. So what we can say is that the distribution function of z is just equals to the area between this region, and we need to respectively calculate z between 1 and 2 and z between 2 and 3. That is because we can see this in this figure. This is just the region that the joint density function equals to 1, and if the z equals to x plus y is under the dot line, we can say what we need to calculate is this area, this triangle, the area of this triangle. But if z is bigger and z equals to plus x plus y is over this dot line, what we need to calculate is the area of this area, and this area is just equals to the area of the cubic minus this small triangle. So finally, what we get is that if the z is between 1 and 2, the distribution function of z is the half of z minus 1 to 2. And if the density, if z is between 2 and 3, the distribution function is equals to y minus half of 3 minus 1 to 2. And take a derivative, we can get the density function of z, and this is just equals to the previous. So this is the first question.